All right, so I go down here to the signature assignment exam, and this, you should have this link for the 500 height and shoe sizes. And this is the link for the PDF that you went and printed. The instructions of the signature assignment say to use a systematic sample. So that means we are going to need to pick a starting point and then pick an amount that we want to step over, our step size. So we'll pick some starting point, and then I'll have to add to it some step size, but that step size will keep increasing through a collection of integers. First, that integer n will be 0, and then 1, and then 2, and so on. Now I need to have 9 samples in total. So this means that n will vary from 0 up to 8. Because if you were to count these, 1, 2, that would be the 9th. So you'll get 9 data points from this strategy, which is called the systematic sample. Okay, so I have 500 data points to choose from. All we need to do is make sure that wherever we're starting at, plus 8 times whatever our step size is less than 500. So that way we won't go off the end of the list. All right, you can pick anything you want. Maybe not something that's ridiculous. I wouldn't pick them both to be 1, right? That's cheap. If they were both 1, then your sample would be 1 plus 0, 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4. It would be the first 9. All right. Now that's acceptable. Well, that's technically a systematic sample. However, these numbers were supposed to be picked at random. If you deliberately pick them both to be 1, I would probably say that it's a convenient sample. All right, so I should pick 2 numbers at random. For it to truly be random, I should use a random number table or a random number generator, but I will just pick something. Like, let's say 11 and 8. Okay. They don't have to be numbers too big. And what this means is I'm going to start at number 11 and then pick the one that's in spot 11. Person number 11 will be my first member of the sample, and then the next one would be number 19. So what I'm going to do is I'm just going to go through and list out the numbers before I even start, because my first one is 11 plus 8 times 0, and the next one is 11 plus 8 times 1, and 11 plus 8 times 2, and so on. You just keep adding 8 over and over. And so I can generate the list of all of my all of the elements of my sample. So the first one will be 11, and then I add 8 and I get 19. And if I add 8, I would get 27, and then 35, and 43, and 51, and 59, and 67, and one more, number 75. So these are the ones I need. Let's see. So number 11 having a height of 70 inches and a shoe size of 10.5. 70 inches and 10.5. And so that takes care of number 11. And number 19 was 69 inches tall with a shoe size of 10.5. $57 height with shoe size 9. And then I need number 35, height of 64, shoe size 9. Were you about to ask something?
I got confused, so when you got 70 and 69.
So these are their heights, and this is their shoe size.
Mm-hmm.
This is their identification number.
Mm-hmm.
So when I look at number 35, I'm looking here at this line.
Okay, I see now.
Yeah, so their name is 35, this is their height, and this is their shoe size. Number 43 and 51 and 59 are my next ones. All right, so I did all of those. You all right?
Are we using the same numbers or do we use different numbers?
Different.
Different.
So I used 11 and 8. You'll just pick something else. So now I'm almost done. I need numbers 67 and 75. So that's a height of 69, shoe size of 12. And then finally, my last person for the sample is number 75. And they have a height of 68, a shoe size of 10.5. Everybody got their numbers picked out? What's up?
I feel like I'm overthinking it.
Okay. Pick me an S and a K.
Okay, so I did 7 and 2.
7 plus 2N. So you would go through and say, this number 7 is my first one.
Okay,
Number 9 is my second one.
I got it.
And it would be all these odd numbers until you, okay. We should describe what our strategy was. For me, it was 11 plus 8N, where N varied between 0 and 8. Right? And that takes care of the strategy used to collect the systematic sample part of the question. For the population, remember, we talked about your population can be pretty much whatever you want. You could pretend that your population was people in your neighborhood, and that this list of 500 was somehow like a random collection of people from the neighborhood. Or you could say that the population is the 500 people. Maybe it's 500 people from the town. I'll just say that the population is the list of 500 people from the list. So that describes the population. If I'm saying it's from the list, then that takes care of the place. There are people from the list. And we did the strategy. Do you believe the sample is representative of the population? I'm not so sure that that question has a right or wrong answer. for it to truly be answerable, we would need to discuss, or I'll say it like this. People, when they make the claim that it does not represent the population, the number one citation they make is that it's an insufficient quantity. But remember, we talked about how to decide what is the correct sample size, and we're not asked to do that here. So I claim that that last question does not really have a right or wrong answer. Okay, if you need to say something, we do. We'll just say yes, that it's representative because it was a systematic sample. It is representative since systematic sampling was used. Then, in part two, so that was part one. Part one's done. Part two, construct a confidence interval. We're actually going to make several. Construct a confidence interval for each of these two different things, the height and the shoe size. So remember, our objective with this is to give an interval of numbers where we believe the population height and shoe size live. Okay. And in order to do that, we need to specify a degree of confidence. And we're going to do this by choosing an alpha. Now, if you remember, alpha and the confidence level are related to one another by the picture that this was the confidence level, and over here is half of alpha, and over here was the other half of alpha. So if you want to say, if you say, I want to do a 95% confidence interval, then this would be 5%. And if you're doing a 99% confidence interval, then this would be 1%. Choose from one of these three and then write down what alpha is right here, because we're going to use that alpha on a hypothesis test here in a moment. I will just do a 95% confidence interval. So, all right. For the other half of this page, they want us to find the sample mean and sample standard deviation of the height. And we're going to denote them like this, which is one of the reasons that we should just fill out this document by hand, because then you don't have to mess around with the symbology. Okay. When I say S sub X, that means that this will be the sample standard deviation of the X values. And X bar is the sample mean of the X values. Well, which ones are the X values? That's the heights. Let's just take heights to be X and shoe size to be Y. Okay. So I will need to open up StatCrunch and type in these numbers. I'll just open up a blank StatCrunch and type this stuff in. So you can either go to any homework assignment and just click the button at the bottom. That works, or you can do what I'm doing. It doesn't matter. So here was my height. All right, and the corresponding shoe sizes were So now I've got my information plugged into StatCrunch. So I'll go to Stat, Summary Stats, Columns. And I can pick both of these. Right? If you have an Apple computer, you have to hold down the Command key to pick both of them. The Command key is the one that looks like this. If you have a regular Windows computer, then you would hold down Control, CTRL. I can hold down the Control key here and pick both of these. You might as well do that, so that way it'll just show you both of them at the same time. And all I'm needing is the mean and the standard deviation. Make sure we're getting the standard deviation, not the standard error. That's not what we're wanting. Okay, so for my x values, the mean was 67.78. We'll just do 2 decimal places, 67.78. And the standard deviation of the height was 6.65. My average shoe sizes were 10.28 with a standard deviation of 3.15. And when I come back here, fill that information in. So X bar was 67.78 and S sub X was 6.65. And for the shoe sizes, I had 10.28 with a standard deviation of 3.15. All right, so we've got that part down. Now we want to do our confidence interval. Well, you are so lucky because we had a way to do it with StatCrunch. We gate, when we had to do the difference of two means, we did it all in StatCrunch. Well, I hope you don't feel that I've abused you during the semester, but we can actually do that same thing right here in StatCrunch. You don't have to do it by hand. If you go to Stat, T-Stats, one sample with summary, it will allow us to do a hypothesis test or a confidence interval. And the alpha that I picked was 0.05, so my confidence level is 0.95. All I need to do is give it the mean, standard deviation, and sample size from my, for whichever test I'm wanting to do. So the first one that we're supposed to do is for the height. So the sample height that I had was 67.78 with a standard deviation of 6.65. The sample size is 9. I have it selected on confidence interval with my same confidence level, and I click compute, and it's going to give me that lower and upper limit. So just to 2 decimal places again, I can get my lower and upper limit for the height. So I'm 95% confident that whatever the average population height is, that it's somewhere between these two numbers. The next part of the question has us find or answer what number is in the center of the interval and what is the margin of error. Why would I want to know that? How did this thing get constructed in the first place? Here we just leveraged technology to deliver us the answer. But that doesn't permit us to not know where it came from. X bar plus or minus the error. It is quite literally the sample mean plus or minus the error. It is the sample mean plus or minus the error. That is where these numbers came from. Every single time you construct a confidence interval, the middle of it is the sample mean. It is your best guess as to what the population mean would be. So this is where we're starting from. But then we're going to add and subtract some amount called the error. And that error, this X bar plus or minus this error, is these two numbers. This number here is exactly X bar minus the error. And this number here is exactly X bar plus the error. You remember doing this? Okay. So we need to tell them what is the number in the center of the interval and what is the margin of error. Well, the number in the center of the interval should be easy. It's X bar. So I'll just say that the center, being X bar, is 67.78. And how can I determine what the margin of error must be without resorting to computing it from the rest of the numbers? Tell me.
Can you just subtract the 67.78 minus 62.67?
Yeah, take this big number minus this small number, and what would I have? No.
Oh. If you want to subtract.
Draw a picture. Right? There's the middle. This is the big number. This is the small number. And if you take their difference, then you will have this length. Okay, but that's not the error. It's related to the error. Tell me what that length is. If you had the center being 5, and this was 6, and this was 4, then what's the margin of error? 1. But what's the difference between 6 and 4? 2. Okay. Divide by 2. You would have to divide by 2. If you take the big number minus the small number, it's twice the error. So we would have to divide by 2, and then we will know another way to phrase this confidence interval. So 72.89 minus 62.67 is twice my error. So when I divide by 2, I get 5.11. So if we had done this the old-fashioned way by calculator, then the thing that we would have gotten was 67.78 plus or minus 5.11. This is what we would have gotten. And we would have had to take that 67.78 and subtract 5.11, we get this. And then we take 67.78 and add 5.11, we get this. And this is our confidence interval. All right, now we're just going to do the very same thing for the shoe size. Now I want to do the confidence interval for the shoe size now. I'll just move this down here, and I'll go to stat, t-stats, one sample, with summary. And this time use my information having to do with the shoe size. So 10.28, 3.15, sample size is still 9. Picking the confidence interval button, still 95% confident, and I hit compute. I get my lower and upper limit. 7.86 and 12.70. Now the numbers that I got were 7.86 and 12.70. But there's a problem here. We'll address it after we say what the center is and the margin of error. Because clearly the center here would be y bar, 10.28, which is just the average of these two numbers. And the margin of error, 2.42. And we're saying that we're saying that 95% of all the shoe sizes should fall in this range. But the last time I bought shoes, they didn't have size 12.7. Okay? So if your foot needs a size 12.7, then what size shoe would you be buying? A 13. And if your foot needs a 7.86, what size shoe would you be buying? So really, this is our best information. Okay, but we should write down all of this. The error, okay. I'll draw you a picture. See these numbers 8 and 13? Okay. Here's a number line. There's 8. There's 13. My question to you is, how far apart are they? 5. This distance is 5. Okay. But the way the confidence interval works is it says, let's start with the number in the middle. And then you have to add an error and you have to subtract an error. So how many errors are there pictured here? 2. Then it must be the case that the length of the interval is 2 errors. Then, when you have more complex numbers like these, you can find the length of this interval in the exact same way you find the length of this interval. 13 minus 8 is 5. So, if I take this number minus this number, it's the length of the interval. And when I divide it in 2, I've got the error. Alternately, you could just say, if this is the number in the center, then how far is it from this right-hand edge? That's 1 error. So, look, what was the confidence interval? X bar plus or minus the error. This was the definition of the confidence interval. We said that the error must be t sub alpha over 2 times s over the square root of n. Now we could do it this way. This term over here is the error. Okay? We will just not have this stuff. We will just say error for now. Because I'm adding and subtracting, I have two numbers. This is exactly x bar minus the error and x bar plus the error. It is this interval. The interval would look like this on the number line. X bar is in the middle, and when I add the error, I'm going to be over here at this number, which must be x bar plus the error. If I subtract the error, then I must be over here at this number, which is x bar minus the error. That's it. Look at how many errors there are here. There's this one, and then there's this one. You can see in the picture then that the distance between the two limits of the interval must be twice the error. The easiest such example I could think of would be 0 plus or minus 1. Here's 0, I'll add 1, I'll subtract 1. What number's in the middle? The thing that I started with is in the middle. How wide is that interval? And that 2 represents how you added 1 here, you took away 1 here. The total length between the two of them must be 2. Therefore, each little segment must be half of 2. This is all that's happening, but with different numbers. So if you you can start anywhere, you start at any number you would like. You can start at 7 plus or minus 1, then this would be 7. And if I add 1 to 7, I would be at 8. If I took away 1 from 7, I would be at 6. The distance between the two of them is still 2 because of this part. This is just a starting point. You go here and you start here. You stand at 7. I'm standing at 7 on the number line. I'm going to go that way by 1 unit. I'm going to go that way by 1 unit. Naturally, the center must still be the place where I started from, right? Okay. Then, when we build the confidence interval, this is how we do it. X bar plus or minus the error. You went to the middle, and you scooted over to the left by some amount. You scooted over to the right by some amount. In this case, I went over to 10.28, and I say, go that way, 2.42, go that way, 2.42, and it makes a symmetric interval around 10.28. That's this thing. Say what? Got it? Look, if you were stuck in a vacuum, if you were in the middle of some place and you didn't have me around or nobody around, and you had two numbers, and you wanted to know what was the center of those two numbers, how would you do it? Forget about statistics. I've got two numbers. How do I find the number in the middle? Take the average. You can get your calculator out. I will find the average of these two numbers. And I think you know how to find the average of two numbers, right? Okay. I will add them together and then divide by how many? 12.7 plus 7.86 divided by 2. It says 10.28. It should not be surprising that this is the very same number, because that's how the thing was built. We said, what is our best guess for the population mean? Well, our best guess for the population mean is the sample mean. Okay, but it's not going to exactly be that. So let's give it some wiggle room on either side. That's what the error is. Hypothesis test. If you still have your StatCrunch window open for the information about the height, you can go back to it and click Options Edit. If you don't have it open, you will just have to type in your stuff again. If I go to options, edit, it brings the thing right back open with my information about the height. And now I can just pick hypothesis test instead of confidence interval. And they're having us check, is the mean height equal to 64 or is it different from 64? And I click compute. They didn't say to check if it's less than or greater than. It's just check if it's different from 64. Tell me what's the initial and alternate hypothesis here. What am I checking? If whether or not it's equal to 64. So my initial hypothesis should be that mu is equal to 64. Here is our initial and alternate hypothesis. They want me to restate the significance level. That's just alpha being 0.05. So it is this very information that we're having to give to the StatCrunch utility in order to get the test conducted right. Make sure you've picked not equals to. It should be the default selection. If you don't pick not equals to, you will get the right test statistic, but the wrong p-value. So my test statistic, 1.71. You just do your test statistic to 2 decimal places. Do your p-value to 3 decimal places, 0.127 for me. Make a sketch of the t-curve with your p-value and test statistic labeled. So what does that p-value mean? What am I supposed to do? I gave it my sample height, my sample standard deviation. I told it there was 9 folks. Why is all this needed? Because the test statistic is x bar minus mu over the quantity s over square root of n. That test statistic is precisely 67.78 minus 64 over 6.65 divided by the square root of 9. I could get out my handheld calculator and type this in and get my test statistic. And maybe it should change back to this. I don't know. But for this semester at least, on the signature assignment, we're getting to not having to do this. When I make this computation, the number that pops out, I get my test statistic. That's what this computation is. What is this p-value? What does it do? Where did it come from? That is true. In fact, I'm glad that you said that. Let's go ahead and fill out that part of the assignment. Complete this sentence. The p-value is the probability, and what did you say? Of being wrong. Is that it? Yeah, it's the probability of being wrong if you reject H0. Okay, this is going to tell me what I should do with the p-value. I want to know, with this part up here, where did the p-value come from? What kind of curve did we study more than any other curve this semester? The normal curve. How much area is there under the normal curve? No. The area is 1. 1 is the number 100%. Naturally, it makes sense that you would have 100% of the area underneath it. Okay. When we started to do probability questions, we would answer stuff like, what's the area to the left of negative 1.5? And we would interpret that as a probability. Probabilities and areas under the curve are the same thing. And you have told me that a p-value, well, it says right here, it's a probability. Okay, I know what to do with that probability, but I need to make a sketch, evidently, of the t-curve that shows my p-value and test statistic. And in that picture, what will the p-value be? It's going to be an area. Okay. Which area? The area in the middle or the area in the tables?
In the middle. The 95%.
No. Is my p-value 95%? No, it's not. It's the area in the tables. The p-value is the area past the test statistic in the tables. We interpret it as a probability because the area under the curve is a probability. Here's my t-curve. The part that's right in the middle is 0. 1.71 being a positive number must be over here then. Negative 1.71 would be over here. It's a two-tailed test, so I need the positive one and the negative one. There, I now have my sketch of the t-curve with the test statistic, and these two areas are my p-value of 0.127. Draw a final conclusion to state whether the evidence is sufficient to support the alternate hypothesis. Does your conclusion agree with the confidence interval from question 2C? Why or why not? Can we answer this last part without looking at anything at all? What did we do when we last week, when you did the stuff from week 8, difference of two means? They had you do hypothesis test and then confidence intervals. And then sometimes they asked you at the very end if that confidence interval agreed with the hypothesis test. And we said that you could drop us off in the middle of the problem, and without looking at anything at all, if we assumed that they did everything correctly, we could answer the question. And we discussed why the confidence interval and the hypothesis test are linked the way that they are. The only way that this could not be true, the only way that you would find yourself saying that they don't agree, is if you made a math error somewhere. You made a computational error. Otherwise, if your computations are correct, they will always agree. They must. If alpha is 0.05, my confidence level is 95 or 95%. 95% and 5%. When they're related like that, when this 0.05 comes from, or not comes from, when I use this point, when I specify alpha to be 0.05, and then say, from this 0.05, I should use the confidence level of 1 minus alpha to be 0.95, they will always agree. And that's what we've had to do here in this assignment. They are going to agree. Look, we should decide, you will see. Let us decide if we're going to reject or fail to reject. What's the probability that I'll be wrong if I reject? It's that number, 12.7%. That's kind of steep. 12.7% chance of being wrong? No, can't do it. Because the limitation is 5%. Can't do more than 5%. And this is saying, go ahead and reject if you'd like, but there's a 12.7% chance you'd be wrong. So I say, okay, maybe I should not reject. So I will fail to reject. My conclusion is to fail to reject. There's insufficient evidence to support the alternate. Insufficient evidence for the alternate. Now look at what it is that I have failed to reject. This thing. I'm saying, you know what? I'm not going to reject this. It looks good to me. It's totally plausible that the mean height could be 64. That's what it failing to reject is telling me. It's saying, I'm okay with this one. Can't find anything to contradict it. Now you go back and look at your confidence interval. Is 64 in here? Then they agree. 64 is in here, and my hypothesis test said that 64 is a plausible number, so they agree. Why do they agree? They agree because 64 is in the confidence interval. What did we say? I said to you that it will always be the case that they agree. It cannot, the only way that they cannot agree is if there is some kind of error that's having been made. Let's track it down. What is your p-value? 0.005. That's pretty small. So you reject it.
I did reject it.
Okay. Then it must be the case that your interval does not contain 64. Is that true?
That's true.
Then they agree. If your interval did contain 64, then 64 would be a plausible number for the mean. But your hypothesis test told you that 64 is not plausible. The hypothesis test says 64 is not plausible. Therefore, when I go to look at my interval, it had better not contain 64. In my case up here, 64 is a plausible number. I failed to reject. 64 is plausible, so 64 had better be in my interval. Correlation. This is what we've been working up to the whole time. Find the linear correlation coefficient. What does this tell you about your data? Well, stat, regression, simple linear. X variable is the first one, the height. Y variable is the second one, the shoe size. That's all you need to click, except for compute. And then you get your 2-page summary. Make the window a little bit bigger of this output here, because we're going to want to take a screenshot of the graph that's on the second page. We're going to want this here in a moment. The first question they asked me is, what is my correlation coefficient? That's this. 0.978. I'll do 3 digits. What does it tell me about the data? It tells me that there is a strong positive correlation. If it had been 0.378, that would be a weak positive correlation. Because remember, the R value, the correlation coefficient, is between -1 and 1, can't be bigger or smaller. If it's exactly 1, then it's a perfect correlation. All of the data points are exactly on a line. This is a strong positive correlation, positive because the number is positive. Also, this positivity tells you that the trend is upward, meaning that as heights increase, so do shoe sizes. And that makes sense to us. Write the equation of the regression line and then use it. So the equation of the regression line is just a couple of lines above it. It says y, variable 2 is y, variable 1 is x. This is y equals b plus mx. So I'll use 2 decimals for each of them. So minus 21.17, that's b, and my slope is 0.46. My equation is y equals b plus mx. If I am to use it to make a prediction, now it says this to use it, so that way you don't go and try and look at the p-value and determine if you should use it, which is what you more correctly should do. But we absolutely would end up using it here because our p-value was so low. The p-value was so low that we knew that we would reject the claim that the correlation coefficient for the population is 0, meaning we're rejecting that there's no correlation. You can look at the picture and certainly tell that the correlation is strong. So we're going to use our equation of the line to make a prediction. What are we predicting here? The shoe size of a person 68 inches tall. So I will compute minus 21.17 plus 0.46 times 68. I get 10.11. Do they have, actually, first of all, is it reasonable? Is it reasonable that someone 68 inches tall should be wearing a size 10 thereabouts shoe? Pretty much. More or less. Would you say it is unreasonable if you got like 150? Yes. There's no one with size shoe 150. But you would not believe how many papers I've gotten that have estimated shoe sizes that are in the hundreds. Okay? Check for reasonableness. Later on, you're going to be administering someone a medication. You're going to need to do the same thing. Is it reasonable that I should be giving this person, this dangerous medication in this quantity? Should always cross your mind. Secondly, they don't make shoes in size 10.11. So what do? So they would need to wear a 10.5. Then I predict that someone of that height would be wearing a size 10.5. Then they want me to create a scatter plot of your data with the corresponding regression line. Oh, that's so fortunate for us because we used StatCrunch, so there it is right there. And I will just take a picture of that. And then it saves it, for Windows at least, it saves it in your, it's just in your clipboard until you do something with it. So here I'll open it and save it to my desktop. And when I submit my file, I will just be sure to attach this as the last document. Some people have taken pictures of the whole thing and then created a PDF where it's one big file. You don't even need to bother with that. You can take picture number 1, picture number 2, and then this is the third file to upload. That's fine. The only thing that's left is number 5. Write a summary about what you have learned from this process and describe the skills that you can now apply because you have taken this course. I would like to hear something about a p-value and regression. That now, when I am reading a document and they say this medicine is effective and we claim this medicine is effective and our p-value was 0.002, you now can know how to interpret that. And if somebody told you, somebody gave you a bunch of data, think of some scenario like they gave you a bunch of data on patient age and cholesterol, and you could now investigate if there was a correlation between age and cholesterol. So, talk to me about something to do with a p-value, how you can use it if you are reading a scholarly paper in the future, and regression. How you could use it in a nursing job.